Hey everyone, we're going to take a look at Achieve section 4.5, number 8. We're to evaluate this limit here. And when I try and just plug in directly, which I should try and do, is this function continuous at 1? Well, if I plug in 1 here, 3 plus 1 is 4. Square root of 4 is 2, so this will be 2. If I plug in 1 here, 1 to any power is 1. I get 2 times 1. I get 2 minus 2, so the top is 0. And if I plug in 1 here, I get 1 minus 6, which is negative 5, plus 5, that's 0. So this is 0 over 0. It's indeterminate. But this section covers L'Hopital's rule, right? And anytime we have a limit as x approaches a, or this can be, limit as x approaches a from the positive side or from the negative side, or as x approaches infinity or minus infinity. If that ratio is infinity over infinity or 0 over 0, and there's a few other stipulations in terms of the behavior of the functions f and g near x equal a. But for most of the functions we'll deal with, if we get this form or this form, then L'Hopital's rule will apply and may be helpful in this is the rule, right? And typically when I use L'Hopital's rule, I'll put a little L over there to indicate I'm using it. But the limit as x approaches a of f divided by g in these cases, only these cases, is equal to the limit as x approaches a of what? The derivative of the top function, right? So f of x, look at f prime of x, over the derivative of the bottom function, g prime of x, right? Again, this is not like a quotient rule or anything. We're not finding the derivative of this function. This is a rule that is specific to finding limits of these forms only, okay? So we can apply L'Hopital's rule, and let's do that. I'm going to take the derivative of the top and then the derivative of the bottom and look at that limit as x approaches 1 of that ratio. To find the derivative of the top, I'm going to rewrite the square root of 3 plus x as 3 plus x to the 1/2. And notice when I take the derivative of that part, I've got to use basically a chain rule. So it's u to the 1/2. So that's 1/2 u to the negative 1/2 time evaluated 3 plus 1 times the derivative of what's inside, right? The inner function is 3 plus x, but the derivative of 3 plus x is just 1. So this is chain rule on the derivative of the square root of 3 plus x. And then I have the derivative here. Well, negative 2 is a constant multiple. X to the 1/2, I bring the 1/2 down. X to the what? Subtract 1 from a half, negative 1/2. So there's the derivative of the top. We'll clean that up. Notice I'm using L'Hopital's rule. I put the little L to indicate I'm using L'Hopital's rule. And we have to include this limit sign. It's incorrect without the limit sign, right? We're still taking the limit. The derivative of the bottom is a piece of cake, right? Polynomial function, derivative of x squared minus 6x plus 5 is just 2x minus 6. I hope that makes sense. Okay. Cleaning this up a little bit, I've got 1/2. 3 plus x to the negative 1/2 is 1 divided by the quantity 3 plus x to the positive 1/2, which is the same as 1 divided by the square root of 3 plus x. So I've got 1/2 times 1 over the square root of 3 plus x times 1, which gives me this. Here, negative 2 times a half is negative 1, and just x to the negative 1/2 is 1 over x to the positive 1/2, or 1 divided by square root of x. So just clean that up. So now, what's the limit as x approaches 1 of this? Does this limit exist, or is it indeterminate? Well, if I plug in x equal 1, 3 plus 1 under the radical gives me 4, and we know what the square root of 4 is. Under here, I get the square root of 1, and we know what the square root of 1 is, and plug in 1 here, and simplifying 2 times what? Square root of 4 is 2. 2 times 2 is 4. I get 1/4. This obviously is 1. And then here I get 2 minus 6 is negative 4. 1/4 minus 1 is negative 3/4, right? 1/4 minus 4/4 is negative 3/4. And so negative 3/4 divided by negative 4, negative divided by negative is positive 3/16. Remember, dividing by 4 is the same as multiplying by the reciprocal 1/4. And there's our limit, 3/16, the exact value. And this is powerful. When we did limits before, it would be very challenging to find this limit using algebraic techniques to try and, simplify. We might use the conjugate up here, to start try and simplify this, but it's not an easy limit to evaluate using those techniques. L'Hopital's rule makes life a lot easier for us. Okay. All right. I hope this is helpful on this one.